So let's look at the questions for this practice test. Don't forget you'll have all the formula given to you and also the symbols on the side there. So using those 5 formula you need to try and solve these problems. So we're looking at travelling the starting speed or starting velocity of VO of 20, accelerating at 3, time of 4. So normally you'd actually put that information there on the side. VO is 20, A is 3, time is 4, and you're after an unknown there, which is velocity. So based on that you choose the equation that fits those quantities. Substitute underneath then, that's 20 plus 3 times 4. Don't forget the 3 times 4 must be done before the addition because of bed mass. And if you add them together, you get 32 metres a second. If they then ask you for the displacement there, the distance travelled, you're looking at S, the displacement, you're going to choose a formula there where S is already on its own. So I'd choose one of these because S is on its own, you don't have to rearrange it. And you would substitute the numbers in there, and you get 20 times 4, which is 80. And you've got to then go and do the other side separately, half times 3 times 4 squared, and then add them together at the end of that. And if you do that, you get 80 plus 24 is 104. In the next one, you've got a ball thrown up in the air. Let's go just stroke this down. At 100 metres a second. So you know the starting velocity of the ball is 100, so you get your VO. You want to find the time it's going to take, so that's time as a question mark, and it's going to be to reach maximum height. Now the key thing here is to be aware that the peak height there, or the maximum height, will occur when the velocity is 0, when it actually stops going up there. So the quantities you need to be concerned with here is a lot of people forget that V at the top is 0, so they forget to do that sort of identification there. The other thing to bear in mind is that it's actually 9.8, negative 9.8 as an acceleration, so a lot of people forget those two parts there. So it's pretty important that you actually remember those parts. When you do that, then you're going to choose a substitution into that formula there involving those quantities. And that would be this one here, and you would substitute straight in underneath. Now the careful thing here is to rearrange it properly. Some people like to do, instead of add 100, you do subtract 100 on the other side and then divide by minus 9.8. Other people like to move the negative 9.8t onto the other side and make it plus 9.8t, and then you're going to divide through by 9.8t. That gives you 10.2 seconds, okay? When you're doing the next one here, the ball dropped. It's going to take 3 seconds to hit the ground. Now dropped means that starting velocity is 0 because it's being released, so it's not being thrown. It's going to take a time of 3, and we want to work out the height it's going to be dropped from, going backwards there. So don't forget the acceleration is 9.8. So when you're substituting there, you've actually got those things there, and again, that will be on the sheet there, minus 9.8 the acceleration due to gravity. Substituting into a formula involving those, you'll find this one we used before. And because it's VO, which is 0 times by anything, this will be 0. 0 times by anything is 0, so you can actually ignore that part here or substitute it as a 0. And you put the rest in as a half of minus 9.8 times 3 squared. And you'll get 44.1 metres. All right. The last one there, this is the plane one. So planes need to achieve a speed of 320 kilometres an hour. So that's going to be the speed it's going to finish with, which is V on its own. And they can't have it in kilometres per hour, so you must convert to metres per second before you start. So we'll talk about that now. It's going to have to be divided by 3.6 to convert to metres per second. If you want to do it the slow way, you would you would times by 1,000 to get it into metres, and divide by 3,600 to go from hours to seconds, because there's 60 by 60 seconds in an hour. But the quickest way is divide by 3.6. Don't forget it's starting off at 0 before it goes along the runway. It's going to have an acceleration that's steady there, and we're trying to find the distance, the length of the runway needed to get the plane airborne. So substituting into a relevant formula that marries all those together, we get this here, and you just do the square, multiply these two together, and you'll get 1291 equals 4.8 s. So to get rid of this times by 4.8, we're going to divide by 4.8. And if you do all that, you'll get a speed of about 1,600 metres. What is it? 1,650 metres. So 1.65 kilometres. So that roughly makes sense for a minimum runway length there. So we need to describe what is happening to the speed of the objects in each of those graphs. So don't forget a distance time graph. The speed is actually given by the slope here. And the reason for that is the slope is y over x step. And we've got a speed as distance or displacement over time. So obviously distance is on the y. Time is on the x, so the two should marry together again. So looking at this, you're starting with a really steep slope through there, so it's going to be going really fast. And then the slope, if you look at it, actually gets weaker and lower until it goes to 0. So if you equate slope with speed, you can say it starts off at a high speed, because it's a steep slope. The speed slows down, and then it stops because the speed is the same as the slope, which is 0. So we're going to do that there. Starts at a high speed, slows down to a stop. You can say decelerates to a stop if you want. In the next one then, if you look at that down here, you've got a steady slope there, which is quite low, so you've got a steady slow speed, and then suddenly here it's actually changing to a steeper slope, so it's now going at a steady high speed. It's steady because the slope is steady. So you need to point out that it's a steady slow speed to start with there first, and suddenly it's going to a high speed because there's a high slope there. Okay, that's sort of the last one then. You should be capable of sort of converting tables here to graphs. So we've got a time versus distance graph, total distance. So there, this is all measuring from the start here. So 0, that's travelled 6, now it's travelled a total of 10, total of 14, and that's the total distance table. To draw the graph of that, make sure you spread out your time on the bottom with even steps, and you put the units in the label. Here we've got the units in the label, I've gone up in even steps there, and I can't really spread that out anymore. So based on that, your first dot point there, or should be done as a cross, is 0, 0 there, so you've got a 0 there, 0. You've got a 0.026, 0.02 and 6 there as a cross. You've got 0.04 and 10. Hard to do this exactly. 0.06 and 14. 0.08 and 16.5, which is around there. It's about a quarter of the way up. And for the 0.10, you've got 17.5, which is in that 3/4 mark of that square. Then you've got to do a line of best fit there through those crosses, which is going to be hard to do on this. On a little pad here is not so easy, but I'll try. It's just a bit too high, but you get the idea there. So it's roughly a curve there. So that means that it's actually slowing down because the slope's slowing down. Okay, thanks.